Detroit. That's right, go Detroit. So now we're going to go right into some cities stuff, which is a big part of the theme also, along with entrepreneurship today. And I'm going to turn over the stage to Carlo Ratti, who's the director of the Sensible City Lab at MIT. And he's going to talk about a very provocative topic, the city as technology. So Carlo, come on out.
Should we go? Yeah. Hello. Good morning. Good morning, everybody. Good morning. Can I have the slides? Yes. So I wanted to start with something that's everybody's talking about these days. It's about big data. Now, big data is about this incredible amount of information we produce today. If we all know from Eric Schmidt quote, if you take all the information that was produced from the beginning of humanity till 2003, well, that's more or less what we produced yesterday and today, over the past couple of days. There's another way, the most fun definition of big data I heard recently by Mike Batty in Singapore a few weeks ago was, well, big data is also all what you cannot put in an Excel spreadsheet. But this big data has big consequences in cities, and that's what I would like to talk to you about today. Call it big urban data. Now, our cities over the past few years have been layered with many different types of networks, with many different types of digital information. And because of that, the way we understand them and the way we can respond to them, we believe is changing dramatically. We can collect a lot of information from our cities, and then we can process the information and respond to that information. I just wanted to make an example of something that has been happening in other fields like Formula One. Well, if you think about Formula One 10, 15 years ago, if you wanted to win a race, you needed a good car and a good driver. You needed physical, solid things. But actually today, if you want to win a race, you also need something like this. A system made of thousands and thousands of computers, so made of thousands and thousands of sensors connected to those computers. A lot of information is analyzed, is collected from the race, is processed, and then decisions are made in real time. And that's a little bit the same that's happening today in our cities. If you are an engineer, you would call this a real-time control system, a system that's basically made of two components, a sensing component and an actuating component. Sensing, you collect information, and then actuating, you respond to that information. And sensing and actuating is really what every dynamic system does, and what every living system does. When we meet each other, we sense each other, we collect information, we look at each other, we touch each other, we smell each other, and then we respond to that information. Now, the amazing thing is that we believe that then almost like every atom out there in our cities is becoming like a sensor and an actuator. And I only have a few minutes today, but I want to share with you a couple of projects that show these two dimensions. The first project started by looking at something we think it's a big issue today, and it's about that computer. If you take that computer, you know everything about it. Every chip in that computer, you know where it was produced, how it moved across the planet, how it became that machine and came to your desk. In other terms, the global supply chain is very well understood today. However, a few years from now, when we throw away that computer, we know very little about it, and sometimes this is actually what happens to it. So what we decided to do was, recently was, what if we put little chips onto electronic waste and other type of waste? What if we then track trash? So put little chips to follow trash and see what happens to it. We did a first deployment that you see here in Seattle, involving really 500 people and 3,000 smart tags. There's a little bit of sound if you can have it. Well, every possible type of object, and then following this, we started tracing and tracking the waste. Should be a video? Yes. So 3,000 objects, you see Seattle, and the day of deployment, you see the city. After a few days, you see some of the main landfills next to Seattle. And then, but then big surprise, how far things started to travel. That was a big surprise because today, everybody knows a small piece of the chain, but this was actually one of the first times where we could actually follow the whole, trace the whole chain from the beginning till the end after 1 month or 2 months. And a lot of e-waste actually traveling all across the country, sometimes in clumsy ways. Look at the trace that went from Seattle to Chicago and then down to Baja California for thousands and thousands of kilometers, certainly in a non-optimized way. Well, you know, what did we learn from this project? Well, a couple of things. One is if we have all this information from our cities, in this case about waste and you know, what happens to things we throw away, then we can probably redesign, as engineers, optimize such systems. So we can reduce a lot of the inefficiencies that you saw in those traces. Then another thing we thought was is quite important is that all of this big data, if it gives us information about what happens out there, then it can promote behavioral change. And actually one of the most telling things following the project was somebody who told us, well, you know, I used to drink water in plastic bottles and put plastic bottles outside of my door every day and thinking it would disappear. But actually, following the project, I know they don't disappear. They actually go a few miles from home and stay there forever. And now, because of this, I stopped drinking water in plastic bottles. Now, there's a third thing we actually discovered that was more recently, and that was quite unexpected. That's when a burglar came to our lab at MIT and stole a lot of stuff, including some of the tags that tell you where they go. And here is a video about it. If you can still try to fix the sound, it might be useful, might be more fun. Yeah. Anyway, there's a bit of sound. But anyway, that was one of the machines. That's what happened. Thank you. Well, this was just a quick example about sensing. I wanted to share with you another example about when you put more data streams together. That's what we are doing in Singapore. So this was using sensors onto trash. But imagine you really can collect much more information and get to almost like a living city, where you know in real time all what's happening around yourself. So here is data in Singapore from all of the networks. It tells you how the city is behaving by using all of these digital telecommunication networks, smart grid, and also how much energy you're consuming and how that is related to temperature increase, as you see here. How the city behaves during special events. You see the Formula One racing in Singapore, and actually how people move there and the city changes behavior. Even simple things like you mix taxis and rain. In Singapore, it's impossible to find a taxi when it rains. But actually, when you get this real-time information, taxi drivers and citizens can get a better match. And how the city expands and shrinks because of traffic during the day. And then how all this information from the island, from Singapore as a city and as an island, actually connect with the global flows. The global flows of people coming to Singapore and going out of Singapore, goods coming in the city and out of the city. So how all of this real-time, almost like a real-time web that has all this information about the city and helps you understand better what's going on. Now, in the last couple of minutes, I wanted to share with you a final project That's about more the actuation side. So we see here, sensing the collection information, but how this actually can change our buildings, our cities, and the objects we use in the cities. And just very briefly, a quick video about a project in Copenhagen. The mayor came to us a few years ago with a very precise question that was, how can all of this data, all of this technology help us to make the city more sustainable and change the way we move? Now, the incredible thing if you go to Copenhagen is that traffic in the city looks like this. Copenhagen is a city where you had a lot of cars in the city center till a few decades ago. And it's a city where now actually have 30 to 50% of all trips every day done by bicycle. And so based on that, we developed this bicycle idea that you can see in the video. Now, I don't know if we can put the audio, otherwise I'll... Well, anyway, the idea is imagine a wheel that you can retrofit to any bike, and then when you brake, so the wheel will get your energy and then give it back to you. So by just changing the wheel, you will convert your bike almost in something similar to a Toyota Prius. When you brake, you save your energy, give it back to you. You control it through your cell phone, through your smartphone. And then, when you do that, you actually can do a number of other things. So you can monitor what you're doing. You can collect information about air quality, like in this case. So it tells you what's the best way to move inside the city. That's air quality data collected for Copenhagen. And all of this, then you can share with your friends. You can just put it on Facebook. With other cyclists, so it creates a community there, or something that the mayor thought was a very good way to increase even more the number of cyclists in Copenhagen, do something like a frequent flyer scheme, but based on green miles. So instead of collecting air miles, you collect green miles, and it becomes a way to incentivize the use of the bike in the city. So that's a video. That was the initial prototype. Now we have the third round of engineering, like in cars, in the car industry. It takes, as you know, a few years to go from the prototype to the final product, but we're getting very close to it, and hopefully it will be on sale next year. So I'll stop here, and thank you.